Hey everyone, and welcome to Computer Science Made Easy. Today we're diving into something super interesting that's happening behind the scenes in the AI world. It's a powerful shortcut called model distillation. Now, it's making AI way cheaper and faster for everyone, but, and this is a big but, it comes with some pretty serious risks that we need to talk about. So let me just ask you something right off the bat. When you're chatting with your favorite AI tool, do you ever stop and wonder if you're talking to an original, one-of-a-kind model, or are you actually talking to a copy? It's a simple question, but the answer is getting more and more complicated, and it's at the very heart of what we're going to explore today. All right, so why on earth would anyone want to copy an AI in the first place? Well, to get that, we need to pull back the curtain on AI's biggest, most expensive secret, the absolutely astronomical cost of building one of these things from the ground up. Yeah, you are seeing that right. We're talking about a price tag of up to, and sometimes over, $1 billion. That's just to train one single ground truth model. That's an AI that learns directly from a massive ocean of original human-made data. This incredible cost creates this huge wall where only a handful of giant tech companies can even afford to play the game. So how can smaller companies ever hope to compete? How does the industry keep innovating if only a few players can afford to build? Well, that brings us to a really clever and, yeah, kind of controversial solution: model distillation. So what exactly is it? The best way to think about it is like a master and an apprentice. A smaller student model doesn't have to read the entire internet. Instead, it learns by watching and mimicking a huge, already trained teacher model. It's a shortcut to getting smart, fast, without having to do all the original, expensive homework. Let's break that down just a little more. You've got the teacher model. This is the original, the ground truth expert who basically read the entire library. Then you have the student model. That's the distilled one. It learns by studying the teacher's super condensed notes instead of trying to read all those books itself. The process itself is, well, it's kind of like digital brain grafting, which sounds wild, I know, but it works in 3 main steps. First, the student just hammers the teacher model with tons of questions. Then, and this is the really clever part, it doesn't just look at the final answer. It watches the teacher's entire thought process, its step-by-step logic. And finally, it tweaks its own internal wiring to copy that same reasoning. And the reason people do this? The payoff is just massive. In the AI industry, this is seen as the closest thing to a free lunch. Training costs plummet, the new models run way faster on much cheaper computers, and it suddenly cracks the door open for smaller companies and startups to create some really powerful tools. It's a huge deal for innovation. But, as they say, there's no such thing as a free lunch. There's always a hidden cost. And in this case, that cost can be quality. Which brings us to what some researchers are calling the photocopy problem. This quote from a researcher really it hits the nail on the head. It captures this growing anxiety in the AI world. I mean, if a student learns from a teacher, and then a new student learns from that first student, you see where this is going. We get a copy of a copy of a copy. And anyone who's ever used a copy machine knows exactly what happens. The picture gets fuzzier and more distorted every single time. This leads to a genuinely worrying long-term risk called model collapse. This is what happens when the whole AI world starts to become a giant echo chamber. The models start training on the clean, synthetic, kind of averaged out data from other AIs instead of the messy, weird, and wonderfully diverse data that comes from actual humans. So this feedback loop is the real danger here. An AI learns from another AI, which learned from another AI, and on it goes. After a while, these models can start to lose their grip on reality. They lose touch with the strange, unique, and sometimes contradictory knowledge that makes up the real world. They get really, really good at sounding confident, but their knowledge is just a shallow reflection of the original. But believe it or not, it gets even worse. The problem isn't just that the facts can get a little blurry. The actual process of thinking, the model's logic, can get polluted. And that is a much more subtle and, frankly, more dangerous problem. It's something called chain of thought pollution. So a distilled model might give you an answer with this perfectly laid out step-by-step argument that looks totally logical. But here's the catch. The final conclusion is completely, factually wrong. Maybe even mathematically impossible. And because it's so good at mimicking the style of correct reasoning without actually understanding it, the error becomes almost impossible for a regular person to catch. Okay, to get why this happens, we need to geek out just for a second on how AI brains are built. You've got two main types. First, there are dense models. Think of these as using their entire brain for every single question. It's thorough, but it's slow. Then you have mixture of experts models, or MOE for short. These are built for pure speed, using only tiny, specialized parts of their brain for any given task. Okay, so we've talked about models getting things wrong, but what about when they do things that are actively dangerous? This is another critical issue with distillation. The safety features, all those ethical guardrails that companies spend so much time building, can just fade away. You have to understand, safety isn't just a simple feature you can copy and paste. It's a really complex system that's been fine-tuned with thousands of hours of expensive, human-led training. When a student model copies the teacher, it often gets the surface-level knowledge, but it fails to inherit this deep, nuanced wisdom. It learns what to say, but it doesn't learn what not to say. And if you want to see just how bad this can be, just look at these numbers. They're just staggering. When researchers tried to jailbreak these models with malicious questions, the big flagship models only failed about 8% of the time. But some of these distilled copycat models, they failed a whopping 94% of the time. It just goes to show how fragile their safety programming really is. So as we start to wrap up here, what this all comes down to is a really fundamental trade-off. It's a battle the entire AI industry is fighting right now, the constant pull between efficiency and integrity. This table really lays it all out, doesn't it? On one hand, you have the promise of efficiency. It's cheaper, it's faster, it means more people can innovate. That's the good news. But on the other side, you have the peril to its integrity. It can amplify flaws, its safety features can get stripped away, and we face this long-term risk of model collapse. And that really is the big question I want to leave you with. We all want AI that's fast, cheap, and available to everyone. But as we race down that road, how do we make sure it also stays truthful? How do we ensure it stays safe? What kind of guardrails do we need? I would genuinely love to know what you think, so please drop a comment down below. Hey, thanks so much for sticking with me through this one. If you found this helpful and learned something new, do me a favor and hit that subscribe button, and maybe share this explainer with a friend. It's the best way to support the channel. I'll see you in the next one.